Hi, um, welcome to CS 340. A couple of things to note straight away. First, you might want to pin either my video, but probably more preferentially Payman's video. Payman Gulami is in the list of people who are participating. He is one of the TAs for the course, and his job, among many others, will be to monitor the chat messages and other interactions with you and bring them forward during this lecture period. If you have questions or comments or something like that, please put them in the chat channel. And if they're excessively important, please bring them to my attention by unmuting yourself and actually directly asking. Of course, there's this is a large course. I'm having to press admit like 100 million times. There are 150 people signed up for the course, so excessive interruptions would be pretty difficult to manage. Payman can sort of represent you to me as we're going. A convenient thing is that Payman will be with us through the entire term and will also ask questions and keep me on my toes to make sure that whatever I'm saying is reasonably cogent and makes sense, and I'm not going too fast or too slow or anything like that. Okay, so this is CPSC 340, Machine Learning and Data Mining. My name is Frank Wood again, and the course website is right there on the front page. Most of the information for this course is, in fact, on that page, not in Canvas, although Canvas has the links for the Zoom meeting information. I never like taking courses without actually knowing something about the people who are teaching me. Again, my name is Frank. Please call me Frank. That's preferred, unless you're in trouble or asking for a special favor or something like that, in which case it's Dr. Wood, but please preferentially in all our communication call me Frank. I'm a computer scientist through and through. I did a computer science degree at Cornell and a PhD at Brown. I was a postdoc at the Gatsby unit at the University College London, which is one of the epicenters for modern machine learning. For instance, DeepMind was spun out of there, that sort of thing. I started as a statistics professor at Columbia, then moved over to Oxford to be an information engineering professor, and then came here for family reasons largely, and am an associate professor here in the computer science department. I'm also a CFAR AI chair, that's the Canadian Institute for Advanced Research chair, and I'm associated to the Mila Institute in Montreal. I'm a researcher principally. My research focuses in deep probabilistic programming, unsupervised machine learning, and artificial intelligence. And as you can tell just by looking at me, I'm old. So I was a .com kid, actually back when being a .com kid was a thing. So I actually didn't start as an academic. I started as somebody who worked in industry. If you've used Interfolio, I was the CEO of Interfolio for a little while. And I continued doing entrepreneurial things. I've spun an autonomous driving company, a technology company out of UBC called Inverted AI, which is operating in stealth mode in Chinatown here in Vancouver. I'm not very active on social media, but you're welcome to follow me on Twitter. It's Frank Donald Wood. I'll usually occasionally say snarky things about 340 and its participants. I run the largest and most well-funded machine learning group in Western Canada, and one of the biggest in Canada in general. It's called the Programming Languages for Artificial Intelligence Group. I have a couple of postdocs, 12 PhD students more or less, a master's student. We do a lot of work with DARPA, which is the Defense Advanced Research Projects Agency out of the United States, focusing on automating machine learning, basically automating everything that we do in CS 340 so that nobody ever has to actually learn the stuff that we do here. And meta learning and sort of human-like rapid inference and learning under the Learning with Less Labels program. Intel funds us to do a lot of large-scale simulation, control of simulation research. We got a little bit of press coverage for work that we did on the Large Hadron Collider. And I'm funded by INSERC here in Canada, the Canadian Institute for Advanced Research, Compute Canada, so on and so forth. So if you see the Play logo around, that's me and my group. Of course, it's my group that does all the work. Before we get started, I should give massive kudos and credit to the originator of this course, Mark Schmidt, who's another phenomenal machine learning researcher here at UBC. he designed slides, he designed the initial homeworks, he did the general course design, that sort of stuff. And honestly, his sort of, besides being a world-class machine learning optimization researcher, the clarity of his synthesis and of ideas is really second to none. And at points during this course, I will actually laugh out loud at the mechanisms and paths by which he introduced all of us, but will introduce you through these materials to very, very complex ideas in machine learning that seem in the context of CS 340 as actually rather simple. Mike Delbert is also responsible for a collection of pre-existing online lecture recordings, which I'll point you to as resources that you can utilize throughout the term, and the Pythonic nature of the homeworks in the course. Great. Okay. Obviously, before we get started, I should acknowledge the scholar strike that's taking place in Canada, inspired by the Black Lives Matter movement started in the US, and say that even though we are going to continue putting forward course materials during this time, it is certainly the case that lots of people face unbelievable amounts of friction, discrimination, disadvantage, so on and so forth, in the achievement of their life goals and so on and so forth. I take the sort of safe space. UBC is a safe space mantra very, very seriously. It's the first thing you would see when you walk in my office. And we will endeavor very, very strongly to not add additional friction or bumps on whatever path you're on. Yeah, hopefully that spirit resonates throughout the course. And if we make any mistakes in that respect, particularly I tend to make jokes, but not of any sort of bad character, but you know, bear in mind that we're doing our best and we care a lot, actually. So that being said, why are we here? Well, obviously you need to take some sort of courses to graduate, or to start your graduate degree or whatever your particular circumstance is. We're in a sort of a very special point in time, right? There's this big data phenomenon that's going on, where all the services that we use, I mean, most prevalent in the news, all the services that we use collect and store and utilize huge amounts of data. And unfortunately, often personal data now, but it's not just that. You know, obviously you can use YouTube, Facebook, that sort of thing, but every time you do a credit card transaction, if you have a credit card, make an Amazon purchase, that forms a data record, and that there is some value associated with extracting information from that. You move around, there's data associated to you moving around, you know, so on and so forth. There's just massive amounts of data floating around, and what do you do with it is kind of the principal concern that drives people into the field of machine learning, and inspires a lot of the methods and techniques that we work on. So what do we do with all of this data, right? So it's pretty clear, and it's that there's too much data to search through manually, right? You can't look at the Google Maps logs and manually try to figure out where everybody's home is, but you could actually look through those logs automatically and actually form some sort of a machine learning task to guess where everybody actually lives based on their movement data, that sort of thing, right? That kind of information is valuable. And the question really is, you know, how do we use it? How do we use this massive amount of data to get at the bits and patterns and so on and so forth in the data that are fun or profitable or even useful in the greater good sense? Data mining and machine learning in particular, are the key tools that we use to make sense of very large data sets. Now, the course title is Data Mining Machine Learning. This is just a machine learning course. What is data mining? Well, it's basically the automatic extraction of knowledge from large data sets. It's usually helpful for human decision making. What is machine learning? Well, it's using a computer to automatically detect patterns of data and use them to make predictions or decisions. They're pretty close. Machine learning in general is most useful when we want to automate something that a human can do. And to do things that humans cannot do, like look at absolutely massive amounts of data. So, obviously, if you looked at the mobility data of every single person, you could figure out on an individual basis probably where they live, where they work, where the schools are, and so on and so forth. But we can't do it at scale, so we need automated methods to do that. On the spectrum between data mining and machine learning, you could say, and this is, they're similar in some respects, but data mining as a field is definitely closer to databases and these sorts of things. Machine learning as a field is closer to artificial intelligence. And in some sense, data mining and databases, there's humans in the loop, basically. You're doing rule associated mining, or you're like fiddling with algorithms to extract little bits of information from a big data set. Machine learning is, in general, inspired by the pursuit of artificial general intelligence or something like that. We'd like to come up with models, algorithms, so on and so forth, that wholly replicate or wholly replace human ability to reason and to draw inferences. Both data mining and machine learning share some similarity with statistics. I am a statistical machine learning person. I wish that we did a little bit more of that in this course. And I sometimes get in fights with my machine learning friends by saying that machine learning is just statistics, but in fact, that's not really true. Machine learning puts a great deal more emphasis on large data sets rather than small data sets. So statistics is about squeezing as much information as you can out of a small amount of data in general. And machine learning is about large-scale computation, like making algorithms go fast and performant, right? Also, statistics is usually about explaining data, testing hypotheses using a particular data set, and machine learning is more about making predictions given a data set, like, yeah. And also, machine learning is sort of more about building general models and algorithms that work over a wide variety of problems. So in other words, the way you work as a machine learning person is you take a problem and you map it to one of the tools or techniques that are available. As a working statistician, quite often, not as a data scientist, but as a working statistician, quite often you'll take a data set and build a bespoke model and a bespoke set of tools to now analyze that data, okay? Great. The question that everybody asks in these circumstances is, okay, well, we've got, deep learning, isn't everything done, right? Like deep learning, we're done, right? Well, in terms of the relationship between deep learning, machine learning, and artificial intelligence, basically, artificial intelligence has a whole lot of stuff in it. Machine learning is a part of what artificial intelligence is. It's basically a particular set of algorithmic and approaches within artificial intelligence, and deep learning is a subset of machine learning. So we're gonna look at deep learning at the end of the course, and you'll play with various neural net models and that sort of thing and ways of training them. But machine learning and what's actually useful in reality, even still today, is broader than just deep learning. If you were to go out with only deep learning in your toolbox, you would fail to be useful in a very wide variety of circumstances. There are zillions and zillions of applications out there now for the kinds of models and techniques that we're going to talk about in this course. Many of you are not old enough to remember email before spam filtering. Email before spam filtering was terrible. Automated methods for determining based on context and metadata and contents whether an email is spam or not in a user-specific kind of a way is an amazing application of large-scale machine learning techniques. Credit card fraud detection in an automated fashion, another such application. Product recommendations, like when you go to Amazon and you buy something, you put something in your shopping cart, and there are other automatic recommendations made to you. This is another large-scale machine learning task that we'll cover in terms of techniques in this course. Video game interfaces that do motion capture, basically capturing pose and what you're doing. starting with the, what was it? What was the Xbox controller? The Kinect, is that right? I have two in my office. That's a place for you to fill in for the audience payment. Is that right? Xbox Kinect?
Yeah, Kinect.
Yeah. So that's, that was random forest based on a bag of features. We'll talk about that. OCR, optical character recognition and machine translation. I have lots of food allergies. I cannot exist in any East Asian countries without the technologies that exist now. I'm allergic to wheat, so and soy sauce has wheat in it randomly. It makes it very complicated. Speech recognition, we all are aware of this. Face detection, even the simple act of unlocking your phone now requires machine learning in order to make that happen. Object detection for various applications, including kind of self-driving car applications that I was talking about before. I should warn you that Mark is a huge sports fan and was actually a very active athlete. So too is I, but I wasn't so good at basketball. Mark really likes basketball, so there's going to be a lot of basketball examples. So if for some reason you either hate basketball or are culturally unfamiliar with basketball, read a little bit about the NBA, learn a little bit about the rules. It's going to help you a lot as you go through the course. In particular, you should really know that this line right here is the 3-point line, and that's the foul line, and shots from in here, like the basket is here, and shots from in closer are easier to make, and these sorts of things. So you should definitely look that up. I think the NBA playoffs are on right now. I don't care. Watch a couple of games. It'll help you in this course. More machine learning applications. They're everywhere. Personal assistants, right? Medical imaging, identifying tumors, and so on and so forth in various parts of the body. And of course, self-driving cars. Elon Musk is totally lying when he says that self-driving cars are going to be here next year. But we are not lying by saying that the things that we'll cover in this course are foundational for achieving the aims of the autonomous driving industry. If you have a crappy old photograph that you've bent or scratched or something like that, or you have an ex-partner, girlfriend, boyfriend, who knows, whatever, that you want to cancel out of an image, you want to do scene completion. It's a nice little thing that you might want to have on your phone. Well, this is another application of machine learning techniques. Image annotation has gotten to the point that it's kind of ridiculous. You can take images and feed them into neural networks and automatically get out captions of what is actually appearing in the image. Our own Leon Segal, one of the other faculty members here in the computer science department, is one of the world's leading experts on this. Will basketball be on the exam? If there were no COVID, I would suggest that maybe the examination should involve some sort of round robin tournament of the students, the winner of which would get A's or something like that. But unfortunately, we can't do that because of physical distancing. And I know you don't mean basketball in the exam like that. There are lots of medical applications that arise from doing unsupervised machine learning of the form of sort of hierarchical clustering and so on and so forth on gene expression data. And on the forefront of modern machine learning are actually techniques, and I work on these personally with part of my team, that fully automate everything that we're going to talk about in the course in terms of model selection, hyperparameter selection, and so on and so forth. And something that will come up a couple of times during the course is the automated statistician, which basically automatically selects amongst a large number of regression models, produces reports for you about what the features were that they chose, so on and so forth. This will make more sense as we go along. But for those who are curious, looking up the automated statistician is kind of a fun what's next out there target to look back at. There are fun, demo applications where you can take an image of someplace in the Netherlands and do style transfer by doing funny gradient tricks inside of a neural network. We can use neural networks now. My group also does a fair amount of this with Convergent and Boeing, where you can take very slow computational processes, simulators, and replace subparts of those with machine learned models that make like computational fluid dynamic simulation subcomponents much faster than actually doing a physics-based simulation. You just sort of do a machine learning model and fit the inputs and the outputs of this particular subcomponent of the simulator. This is quite common in computer graphics and in various kinds of simulation now. And of course, everybody has seen the buzz and the hype from DeepMind, where they use Monte Carlo tree search and various reinforcement learning applications approaches, to exceed human performance in Go and StarCraft. Again, we're not going to get to reinforcement learning in this particular course. I'm working with Mark to design 440 for the next term, where we will get to reinforcement learning at the end, particularly looking at it as inference. But the stuff that we're going to talk about in this course is very foundational. You need it. So summary basically is sort of where we are and how what we're going to talk about relates to the applications that we just talked about is really that with just a teeny little bit of statistics. And again, because of my personal research preferences, I really wish that there were more statistics in this course, but you don't actually really need a whole lot of statistics. With a little bit of statistics and a huge amount of data and a lot of computation, you can do pretty crazy things now, right? We're really in very, very exciting times. We see on a day in and day out basis on our own personal devices, the progress that's being made in speech recognition and computer vision, right? 3 to 5 years, it's impossible to keep up, right? But what's good about this course is that the stuff that we're going to cover is foundational. It's the stuff that actually has survived the test of time, right? Even research is crazy. I think NeurIPS admits 10,000 people a year, something like that. Last year it sold out in 11 minutes, right? And of course, there's a huge amount of cash being thrown around to support quote unquote AI companies. And of course, there's very, very few companies that are actually doing AI. Most are just doing machine learning of some kind or another. Maybe the most important thing you'll get from this course is a notion of what the various techniques in machine learning are actually good at and are actually good for, right? So it's maybe more important to actually know the limitations of what can be done. The Tukey quote that's listed here that you can read on your own basically suggests that, just because you have a bunch of data and you really want to get some sort of valuable insight from it doesn't mean that this is going to happen, right? It doesn't mean that the model that you apply is necessarily going to do what you want it to. And there's a lot of stumbling blocks, conceptual, procedural, so on and so forth, that taking 340 can help you avoid. Like a classic example is sitting in on graduate examinations in other departments where people use machine learning and use it very, very inappropriately. They overfit, they don't understand the assumptions they've made, and they find that basically if they release their methods out into the wild, they don't work. Great.
So someone's asking, are the materials in CS332 are not going to be?
I don't remember CS322, so I'd have to look up CS322. So I might have to punt on that one and claim ignorance. What's in CS322? Somebody say more classical AI stuff. Oh, is that David Poole's course basically? Yeah, no. So this basically there's no overlap between what we cover here and in 322. So yeah. So as a sort of rhetorical and pedagogical technique, we're going to have these pause slides intermixed occasionally. And normally what I do in class is make everybody really uncomfortable for 2 minutes and wait for people to actually ask questions. So in the previous lecture today, I was unable to make people uncomfortable at a distance over Zoom. I'll try to figure out a way to make people uncomfortable so that they actually ask questions. But when you see these pauses, it's an extra time for you to reach out with questions. So are there questions at this point? How rigorous will the statistics component of this course be? Not particularly. It depends on what your notion of rigorous in terms of, for a statistician, what we do is a joke. For a computer scientist, it's going to seem crazily rigorous. Yeah, we'll talk about what maths are required actually the best way to get a sense of what's required is the homework, which has been released today. That will give you a very good sense of what's required. But it's linear algebra, calculus, probability, some basic stats, but probability, multivariate calculus, and linear algebra are really the things you need. Okay, that's an interesting question. So the question is, I think the previous slides said that companies are doing AI, really doing machine learning. What other parts are there to AI than machine learning? So I would say that machine learning is largely about fitting conditional probability estimates or doing nonlinear function approximation, basically mapping some input to some output. By replicating or mimicking some sort of human labeled data. That is, of course, not at all how human beings or any organism learns. We do not learn using supervised learning techniques, and this course is not entirely about supervised learning, but it's heavily influenced by supervised learning techniques. And companies that are doing AI are actually just doing function fitting or something like that in general. Although I suspect that Payman and I could have an interesting conversation about that, because I think he has some industrial experience, but I'm guessing it's no different than what I just said, even though you have some fancy experiences.
Apparently there are people in the waiting room, Frank, if you want to let them in.
Great, thank you. Python. IDEs you can ask about online. So what language? You guys can worry about the IDEs yourself. That's fine. Assignments will have a certain amount of algebra and a fair amount of coding. You can look at the assignments right now. They're all released already. They're on the course website. Okay, so under normal circumstances, we have limited lecture hall capacity and a very very strong incentive to make sure that people who shouldn't be taking the course don't take the course. There are still reasons that you might not want to take this course, and you should think about it and make sure that you're doing the right thing. And I'm sorry about the outside noise. I'm actually in my office, so I can't do anything about it. So for computer scientists, and I always forget this because I'm a machine learning person, and basically what that means is I do math and writing all the time. I do relatively little coding, almost none, in my welcome seniority. Compared to the typical computer science class, there's a lot more math, right? So we require linear algebra, probability, multivariate calculus at the same time. And historically, students have complained about this, and they basically will, and every term students complain, and this is kind of annoying to see this. It's like the prerequisites really should require that students achieve a certain level in their required math courses. If you haven't, it's going to be pretty tough, and you're going to be playing catch up, right? So if you've only taken a couple of math courses, or you have low math grades in those courses, this course can be really tough. It's doable, but you're going to spend 4 months catching up on math and this as well, right? It's arguably better if you're in that situation. Try out the first homework, see how you feel. It's going to get harder from there. It's better to improve your math than take the course later. Okay, this is not a data science in training, data scientist in training class. Is not a course on how to use scikit-learn, TensorFlow, or PyTorch. The point here is we're going to implement everything from scratch. We're going to implement the models we talk about from scratch. You're going to learn how they work. You're going to implement stochastic gradient descent. You're going to implement SVMs. You're going to implement random forest. You're going to implement all sorts of stuff yourself. Okay, that means you need to be comfortable at the 300 level in computer science, right? You need to be able to quickly understand and write code. Even in a new language, you haven't done very much Python coding. You expect to be able to analyze new analyze algorithms and big annotation. And this often comes from graduate students who are coming in from other disciplines, right? If you have limited programming experience, this course is really hard. Now, you might be in a situation where you want to learn anyway, do it, that's fine. But if you're really, really weak on the programming side, it's going to be very difficult. So consider taking a course to improve your programming experience, and then take this later. So we're going to use Python in this course. It's one of the three most used languages in this area. And no, you can't use MATLAB, R, TensorFlow, Julia, We've got assignments have prepared code. We're not going to translate to other languages, and TAs won't grade in other languages. Don't take this course expecting a high grade with low effort, although that's a little bit different in this COVID situation, because we're going to grade very leniently because of the extra difficulties of learning at a distance. It is true, no matter what, that the assignments are long and difficult, right? So if you're not good at math and computer science, you're going to take a lot of time, right? And historically, the class averages have been high because of graduate students, not because it's an easy course, right? Now, Mark likes to put this one in here. It's not this dire in terms of rate my professors, but there's a lot of work. That's it, right? So I'm teaching both sections of 340. You can pretty much mix and match the section. They have the same webpage, they have the same assignments, they have the same examinations, and up to sort of Zoom capacity, you're free-ish to attend the lectures of the other section. So if you decide to move to the other section for whatever scheduling reason, and you're in this one and you decide to go to the earlier section, don't enter the Zoom meeting until slightly after the start of class time, because you could kick people who are supposed to be in that class out. So just be good about that, please. I'm going to try to keep the lectures in sync, do a pretty decent job of that usually, but if I get out of sync for any reason, we'll only test on material that appears in both sections. And I'll point out that next term this course will be taught by Mike Galbert, also probably in Python. Mark and I are research faculty, like that's our focus. Mike is teaching faculty, right? If you want a better learning experience, almost certainly Mike will do a better job. So if you have the flexibility and you're concerned about a lecture style course online, Mike has the capacity to probably do a better job and to specialize more in these COVID times than Mark or I would be able to. Again, for those of you who are looking for a different kind of experience, CPSC 330 is new. It's less advanced. There are fewer prerequisites. It's more of a doing rather than thinking course. I'm not a huge fan of it, but for certain circumstances and certain life circumstances, it makes a lot of sense. It's like, how do you use the tools? When do you use the tools? We talk about how they work and make you actually learn by implementing and that sort of stuff. 330 is more like a Coursera course. So this is not knocking Andrew Ng's course or anything like that. Go take it, but you cover less and in less detail than what we do. There's another more advanced machine learning course, 540. Next term there should be a 440, which is probabilistic machine learning. I'm looking forward to that. The 540 currently starts where this course ends. 440 will cover some of the same material, but cover it from a probabilistic perspective. 540 focuses more on theory and implementation and less on applications. It has higher prerequisites, a higher workload. If you're thinking about the difference between 340 and 540 in terms of shopping, almost everybody's better to start in 340 and make sure you've got your knife sharp. Although there's a Canvas site, and hopefully most of you entered this Zoom meeting through the Canvas site, all of the actual course information besides that is on this course webpage outside of Canvas. Bookmark it, get familiar with it, go to it, use it. It has all the lecture slides, they're all pre-released, all the assignments, they're all pre-released. There's optional readings, they're all released, additional notes, so on and so forth. And you should definitely sign up for Piazza. If you're not familiar with it, most of you are, but some of you are not. You can use it to ask questions about lectures, assignments, and exams. It's used occasionally for course announcements, although important ones will go out through the Faculty Service Center. You should know that I don't particularly watch Piazza. Don't message me directly on Piazza. TAs handle Piazza. And there's a little bit complicated thing is I don't directly read my email. It goes through an assistant. So basically, whatever the issue is, it has to rise to such a level that it will actually get through the assistant. So First course of action, go to Piazza. TAs are phenomenal resources. They're very, very good. Use them extensively. Good news, don't have to buy a textbook. There's no required textbook. There's optional additional readings that you can take. I'm a big fan of the first, third, and fifth books on this list. If you have the means, and you're interested in pursuing machine learning in the long term, I would recommend that you go out and just buy them or get them by some other means. Obviously, the fact that they're in the ISIS reading room doesn't actually help you at all right now because you can't go there, but you can access them online in general, right? There's lots and lots of online resources to cover that cover the material that we cover in this course. We're lucky to be endowed with a very, very good set of TAs. I couldn't update this slide in time for the lecture. The last TA's name is Eric. Payman will be with us and representing you throughout the entirety of this term. So get to know him in particular. Of the only other call out here is for Sharir, who is the quote unquote head TA, first amongst equals, and he will deal with administrative concerns related to missing tutorials or office hours in the wrong time slots, or your dog ate your homework or something like that. There's 6 assignments. They're already all released. They're worth 40% of the final grade. They're a combination of math, programming, and short answer. Because of COVID-19 and this horrible online learning situation that we're in, the grading is going to be very terse and generally very lenient. And it's basically the scores that you're going to get are going to be a product of either you did the homework or you didn't, and either you cheated or you didn't, right? So you can get a 1 if you complete the homework and you don't cheat, and pretty much every other combination gives you a 0, okay? And this is an explicit design in response to the COVID-19 situation, basically, and it makes it very clear and straightforward and upfront and so on and so forth that really, at the end of the day, as in every course, you are responsible for learning. If you go off and do the work, and you really actually are honest with yourself, and you give a good try to everything, that's going to get you a 1. That's good. Just do the work. That's how you learn. A course is basically just a forced succession of little tasks that accumulate to a vast broadening of your understanding about the world, right? Let's just be honest about that. Do the work. If you decide to cheat in a way that we can't tell, so what? Who cares? We don't care, right? It's your loss, right? If you decide to cheat in an obvious way, we're going to nail you to the floor, okay? So best just do the work, okay? The answers to the homeworks will be distributed via Piazza, and you can compare your answers with the distributed answers when they're released. Assignment 1 is on the webpage. It's due next Friday. The assignment instructions are also on the website, and the assignment should give you a pretty good idea of what you need to know in order to survive the course. Don't delay. Start today. And if you're on the waiting list, you're probably going to get into the course, so start. First assignment you have to do by yourself. The next assignments you can do in pairs. You're going to use Gradescope to submit your assignment. Follow the instructions carefully, right? You don't have to have the same assignment forever, same partner for every assignment. Various permutations of partners are allowed. Assignments are due at midnight on the due date. You can use late classes. Late classes are pretty obvious. You can use 2 late classes on a single assignment and 4 late classes throughout the entire year. If you're late more than that, you get a 0. We release the solutions after 2 late classes. No extensions will be considered after this. Don't bother. Lots of grandmothers die, unfortunately. Lots of aunts get married, fortunately. Lots of medical emergencies happen, unfortunately, so on and so forth. This is accommodated by the late policy. It's fine. You can submit more than once. You can always submit something preliminary by the deadline. Also, follow the submission instructions. Get it right. Don't forget your name. Don't forget your student ID. Use your UGrad email alias to identify yourself on Gradescope. Don't screw that up. Don't submit crappy corrupted files. You just get a 0 for it. You're all big people. You can get it right the first time. There's a waiting list. There's no auditing. almost certainly everybody on the waiting list will get in. I'd be very surprised if you didn't. The assignments are long. They're not that easy, right? There's a lot of help. If you look at the course calendar, there are a huge number of TA office hours. There's a huge number of tutorials. The schedule is on the course webpage. We'll adjust to accommodate time zones to the extent we can. Piazza is there for general questions. You are very, very well supported, right? This slide is incorrect. The tutorials actually start this week, so you can start going to tutorials as you wish. You can, go to whichever tutorials you want, whether it's 101 or 103, that's sort of fine. You can go to multiple tutorials as you wish, so on and so forth. They'll go through code and review background material and review big concepts and that sort of stuff. Feel free to talk to the other students in the class. I'm sorry that you can't all congregate in one space so you get to know each other, but use Piazza for that. That works just fine. And the web has resources for almost everything we cover. Midterms and finals are going to be different than in past years. Again, in the COVID-19 accommodation, they'll both be take home. You do it offline in your own time, so on and so forth. No proctorio, that sort of stuff. You don't have to pass the final to pass the course. They'll consist of a couple of different kinds of questions, like short written questions and Kaggle-like competitions. The slides are already posted online. When I screw up and fix them, I'll post new versions eventually, but they're online before lecture. The lectures are recorded. The cloud recordings will be available through the Campus Work website. Ask questions. I might fob you off to Piazza or to the TAs, but we'll do our best to address the questions that come up. You should be warned that we move fast in the course. We cover a lot of topics. The important sort of foundational big ideas will be covered slowly and carefully, but a lot of topics will be covered at a fairly high level, fairly fast. So you can ask, is this wrong? Is this the wrong course design? I argue with Mark about this all the time, but in fact, I think he's right. So in this field, it's actually better to know a lot of methods, know enough about them to be dangerous, and you'll be definitely dangerous by the end of the course, than to know like 5 or 2 or something in extreme detail. And this is basically because you can't know in advance which problem is going to require which method and vice versa. So this is what we'll call the no free lunch theorem throughout the course. In addition to the lecture materials from this term, Mike Gelbert recorded in 2018 a version of the course where he does a lot more hands-on demonstrations and that sort of stuff. Those videos are available. I highly recommend you check them out. Material is basically the same, and you can rewind and fast forward and so on and so forth. And again, he's teaching faculty, so arguably does better. You can't see the difference online, but there are these bonus slides that have kind of a tan puke colored background. I'll flip back and forth. I can't see the difference on my screen, but there is a difference, and you'll see it when you download the slide deck yourself. And I'll call it out when there's a bonus slide. When there's a bonus slide, basically the material isn't covered. It's not fair game. It's covered, but it's not fair game for exam. So you don't have to actually like go off and study it. It's just useful and extra information that you might want to take home. Don't be a jerk. Don't post offensive commentary or comments or disrespectful content on Piazza. If you have a problem or complaint, let us know, either through the head TA first and then through me and my assistant. Don't distribute the course materials without permission. That's a big no-no. And don't distribute the recorded lectures without permission. Be smart about when you go off for help. Don't don't ask a question if you've only spent a couple of seconds thinking about it, so on and so forth. That's annoying for everyone. Make a reasonable effort, but don't put yourself in a world of hurt by struggling with something for hours and hours and hours. Reach out before then. If you do that, then time is going to take all of your time, basically. We're not going to fiddle around with grades. Because of COVID-19, the grading policy is again going to be extremely lenient. The course mark was effectively pass-fail. There's 3 default marks: A+, A, and D. A+ is if you do exemplary work and we identify you as one of the stellar, outstanding students. It's obvious. We'll find those 5% and you'll get an A+. Everybody else, so long as you do your homeworks, you complete the exams, you put in the effort, and we see that you're actually learning, that's all that really matters, you're going to give you an A. On the other hand, if you're one of the 5%, and there will be 5% of you to get a D, that don't do the homeworks, cheat unnecessarily, obviously, we'll give you a D, okay? So think of this as a pass-fail course with an opportunity to get a really, really nice mark in a machine learning course if you do the work and we see that you're doing the work. We'd rather see you do the work than get it absolutely right. Okay, great. Of course, I retain the right to assign any other mark for any other reason. So if you piss me off, you might get a B- just because. Okay. Academic misconduct is a big deal. Don't cheat. I mean, I've sort of acknowledged that it's going to happen, and it does happen, right? And I don't really care because it hurts you more than it does me. But if you do it in an obvious way, we're going to nail you to the ground. Okay, we're like, don't cheat. It's just dumb. Don't cheat. You can find the answers to the homeworks online. Don't use them. Do the work. Again, I'd rather see you try and put in the effort and fail than do a creative job of copying, right? It's just annoying for everybody involved when that happens, okay? And it's really annoying to have to prosecute academic misconduct cases, but I do it anyway. A kid from 2 semesters ago is getting thrown out of UBC, no degree, because of academic misconduct in this course. Don't do it, okay? So cite your sources, and for those of you who come from different backgrounds or different schools or different countries or whatever, I come from a different country, don't take that personally. At Canadian schools at UBC, this sort of cheating and plagiarism thing is taken very, very seriously. Other places, it's maybe a little bit overlooked. Not here. Okay, get serious. That's pretty much it. I'm sorry I ran over. I started a little bit late, so I feel obligated to run a little bit over. That's pretty much it for today. I'll leave you with the course outline for the rest of the term, actually. So the next class discusses exploratory data analysis. Boring. No, it'll be fine. It's pretty straightforward. It's basically like look at the data, compute some plots, that sort of thing. But after that, the course is divided up, not equally, but it's going to feel like it into 5 different topics. We're going to start with supervised learning. We're going to do unsupervised learning. We're going to do linear models, linear prediction. We're going to do latent factor models. Then we're going to hit deep learning. Okay, and that pretty much is it. So I'll stay on until 5 to answer questions. But after that, please post your questions to Piazza, and yeah, let's have fun as much as we can in the circumstances as they are.